Flooding is one major problem our country faces. As with the recent Typhoon Lando, we lose huge amounts of properties and resources every year due to incessant rains. We need to prevent all that water from accumulating on the surface of our roads and footpaths. One company in the UK, Lafarge Tarmac, has invented Top Mix Permeable, a new type of porous concrete that can absorb up to 4,000 liters of water in the first 60 seconds and an average of 600 liters per minute per meter squared. Top Mix Permeable can play a fundamental role in the majority of sustainable urban drainage systems, providing a practical, long-term answer to surface water flooding that can be implemented quickly and cost-effectively. As the world's population continues to shift from rural to urban areas, natural drainage systems are being replaced with impermeable surfaces that hinder the environment's ability to drain rainwater. In a forest, for instance, somewhere between 80 and 90% of rainwater is absorbed back into the ground. In urban areas, that absorption can fall to just 10% of rainwater. This type of concrete is called pervious concrete, also referred to as porous or permeable concrete. It is a porous media which primarily consists of open-graded aggregates bonded by cement-based matrix. It works by having a permeable layer on the surface made up of relatively large pebbles through which water can drain almost instantly. When rainwater falls on top mix, it drains through the porous concrete and a base layer of gravel, filtering out pollutants like motor oil in the process. This is followed by an attenuation layer which feeds the water into a drainage system that connects with the city's groundwater reservoirs. In contrast to traditional water drainage systems, this design proves to be very efficient. Depending on the area that is being paved, Top Mix offers three different design options, ranging from an option that allows all water to permeate back into the soil, System A, to an option that includes an impermeable membrane that allows water to be captured and used for things like irrigation or flushing toilets, System C. If the ground is incapable of absorbing large amounts of rainwater, that water can simply be directed elsewhere. The technology comes with its fair share of limitations. Tarmac warns against using top mix to pave heavily trafficked areas, suggesting it might be more appropriate for places like parking lots and driveways rather than highways. Also, it cannot be used in cold climates because the concrete is likely to be damaged as the water beneath freezes and causes the surface above to buckle and crack. To prevent reduction in permeability, pervious concrete needs to be cleaned regularly. A journal by Zhang and Will describes high-performance pervious concretes. It is characterized by connected pores, typically in the range of 15 to 30% per volume, that allow air and fluids to pass easily from the surface to underlying layers. The product, Top Mix Permeable, has a high void content of between 20 to 35%. Higher amount of matrix leads to reduced total porosity and hydraulic conductivity, but higher compressive strength, whereas lower amount of matrix results in increased total porosity and hydraulic conductivity, but lower compressive strength. Additionally, the aggregate size affects the pore system characteristics, and thus the compressive strength and hydraulic conductivity. Therefore, a balanced ratio and tailored aggregate size are necessary to satisfy both of the competing performance criteria. A related patent shows a pervious concrete applied on a park pavement. The article was in Chinese. Porosity of the patent is 25 to 30%. This technology shows very promising applications in the Philippines where rain flooding is a major concern.